Thank you all so much for joining us. Welcome, Duke alumni and friends, to this session of the Duke Alumni Forever Learning Institute. I'm Eli Kline, Program Coordinator for the Duke Entertainment Media and Arts Network, DEMAN, in alumni engagement, and I'm thrilled to have you with us today. Thank you for joining us for AI and the Future of Musical Creation, a professional development focused session and part of our music appreciation series. In this session, we'll explore how AI is shaping the future of music production and appreciation in an increasingly tech-driven world. This is the second session in our series, and today we'll dive into how AI is reshaping the music industry, opening new doors for professional growth, and revolutionizing the way we create and experience music. Now, I'm delighted to introduce our speaker, Professor John Supko, Associate Professor of Music at Duke University. His work has been described as spellbindingly beautiful in Time Out New York, hypnotic, eerily beautiful in the New York Times, and fascinating in The Guardian. As a composer, he explores the intersections of chance and intention, traditional music notation and real-time score generation, sound and spoken text, installation and performance, and human and computer creativity. A recipient of Fulbright and Georges Lorcy Fellowships, both for Paris, France, Professor Supko studied at the École Normale de Musique. Excuse my pronunciation. His music has been performed across North America, Europe, and Australia, published in collaboration with the poet Philippe Denis, and released on the New Amsterdam and Cotton Goods labels. At Duke, he co-directs the Emergence Labs with Professor Bill Seaman. He holds degrees from Indiana University's Jacobs School of Music and Princeton University. Professor Supko, welcome to the Forever Learning Institute. We're so glad to have you here.
Thank you very much for having me, Eli. I'll just share my screen. Okay, thank you. And thank you all out there in Zoom land for tuning in. I'm delighted to speak to you today about AI and the future of musical creation. So let's get started. I'd like to start with some preliminary remarks. First and most importantly, as you heard, I'm a composer. I'm not a computer scientist. So this talk will be heavy on musical aesthetics and less focused on the nitty-gritty technical details. I'm an associate professor in the Duke Music Department, where I've taught since 2009, and I'm also on the faculty of the Computational Media Arts and Cultures PhD program. I've been writing acoustic and electronic music for about 35 years, and I've also been working with various forms of computational creativity for the last 15 years or so. I like to think that one of the advantages of being an artist working with technology is that I can engineer serendipity, mostly by making lots of mistakes that wind up getting incorporated into my work. In other words, if I knew exactly what I was doing all the time, I wouldn't stumble upon those happy accidents that are so crucial to my sense of creativity. By design, my use of AI is low level, speculative, and collaborative. I think of myself as collaborating with the computer. I often want to edit and develop what the computer comes up with. On this subject, I'd like to play a 30-second excerpt from an interview I did on Drive Time Radio in Australia in 2016. The show is called RN Drive, and I'm reliably told by my Australian PhD advisee that it's one of the most popular radio shows in the country. I will say, though, that the host was quite tough. You'll hear how she subtly suggests that I had been lying to her up until this moment.
John Supko, I'm going to ask you a question. I'd like you to be honest. What music do you prefer? Music made from your computer or music made and generated by people?
Well, I'm not interested in a sort of machine that replaces humans. I'm interested in tools that help humans make more and different kinds of music, unexpected kinds of music. So I'm always interested in a kind of collaborative process with technology.
John Supko, thanks for joining us on RN Drive.
Thank you very much.
So I'm not exactly a starry-eyed futurist. I do have strong critiques of AI, but I am an optimist. I'm excited about what these tools offer artists who want to work differently. For today's talk, I will give an overview of current AI technology for music, accompanied by my thoughts about it, and then I'll share some examples of my own work. But first, I want to talk about intelligence. AI, as I think we all know, stands for artificial intelligence. And the etymology of the word intelligence reveals two Latin words tucked inside of it. Inter, the preposition meaning between, and legere, a verb, as you've probably guessed, meaning to read, from legible, or also in certain contexts, even it can mean choose, to choose, or pick out, or collect and gather in certain contexts. So this is instructive because, of course, humans do this with all sorts of sense data. We choose what to attend to and what to ignore. We collect related information into larger piles, and we infer what these collections mean with higher order concepts and pattern recognition. Indeed, you could say that we are pattern seeking animals. It's how we understand the world and our place in it. Amazingly, if a pattern isn't available, or if the available information doesn't make immediate sense, our brains will invent a pattern or a story that does. There's a great example in William S. Burroughs's novel, The Ticket That Exploded. He says, take a scene of people running to catch a bus in a comic film and remove the funny music accompanying it. Replace the music with a recording of machine gun fire. Our brains will instantly recast the comic scene as something out of a chaotic war film. We compose the world around us with the information we have at hand. In his book, How to Create a Mind from 2012, Ray Kurzweil describes his pattern recognition theory of mind. He says our brains process linguistic information like wet statistical computers. We read from the partial letter level to the word level to the sentence level and so forth. And at every stage, we make pattern completion predictions. That's the statistical part that get updated and corrected as we receive more information. This isn't just a futuristic notion, it's an ancient and a deeply human one. There's a beautiful example of it in Dante, in the Purgatorio, in one of the earthly paradise cantos. Here are two stanzas. I saw next, far ahead, what I believed were 7 golden trees, at such a distance, and in such light the eye can be deceived. But in a while, when I had drawn so near, that chance resemblances, confused by distance, no longer made false images appear. And that goes on. But basically, he's saying, my brain thought it saw one thing far off in the distance, but when I got closer, I saw that it was something else. That's pattern recognition and error correction. In this sense, being intelligent means we can read the world, a natural landscape, a painting, a friend's face, and make continuously updated inferences about our reading. And an artificially intelligent system simulates this human ability to select, connect, and correct. In order to understand how computers might write music, I'd like to do a little listening exercise. I won't reveal just yet what you're about to hear. Instead, I want you to focus on listening to it without judgment. Uh, I want you to try to release all expectations, abandon concepts of good and bad, if only temporarily, and listen as though you're walking in nature or stepping out into a city street. Let's take a deep breath, quiet our minds, and then I'll play the excerpt. I know this is probably strange or at least unusual music for many of you, but trust me, I have a reason for playing it. I'm not ready to tell you what it is just yet, but I will say that despite how it may sound to you, it's probably the most organized music you've ever heard. For this exercise, we will only concentrate on one aspect of that organization. I want you to try to hear some instances of repeated notes. That's it. And to do this, I've made a reduction of the excerpt with only an electronic piano playing the notes, the repeated notes. And then, of course, everything else has been removed for the time being. So we'll listen to that recording now. And before we listen, I just want to point out that something about what we're looking at. On the left, you can see a vertical piano keyboard, with each of the notes labeled. And then horizontally, you can see a representation of the notes played in orange rectangles over time. So this is the time domain. And the rectangles on the same row represent the same note being repeated, although sometimes the repetitions are separated in time, like these F sharps at the end here. There's quite a bit of time between these two repetitions and this final repetition. There's also repetitions of notes in different octaves, like in bar 6. It's a little hard for me to see here. Right here, these A's, they're separated by an octave. So it's the same note, but one is an octave higher than the other. So there are different kinds of repetition. And what I'd like you to do is just listen to this excerpt of repeated notes and see if you can hear certainly the repeated notes when they're in close temporal uh, proximity, but then try to hear some of the notes where you see the same letters, but they're higher or lower in different octaves. As a final step, I'm going to overlay the electronic piano reduction on the original recording. This way, the repeated notes will be emphasized in the full version of the excerpt. The point of this exercise is to hear some clues that there may, after all, be a structure somewhere in this seemingly chaotic tangle of notes, that the repetitions might mean something. What we've been experiencing here is another way to structure and, as a result, listen to and think about music. I hope it has piqued your curiosity. You might even find yourself thinking about this listening experience later today. After all, you've just heard the first 45 seconds of Milton Babbitt's Concerto for Piano and Orchestra 3 times. And far from breeding contempt, I'd like to think that increased familiarity with new kinds of music breeds appreciation. Remember, I'm an optimist. You might reflect on how this listening experience is different from your normal one. The system Babbitt used to compose this music is called, somewhat imposingly, total serialism, which is a development of the famous 12-tone system of Arnold Schoenberg. What Babbitt is working with here is a strict organization of all 12 black and white notes on the piano, that is, the chromatic scale. The resulting order of pitches is called a row or a series, hence the name serialism. It's total because Babbitt is also organizing all the other aspects of music, including register, rhythm, dynamics, and so forth. But it's not just the order of the pitches that interests Babbitt. It's really the distances between them, the intervals created, like the notes we just heard repeated across octaves. And although Babbitt wrote a good deal of electronic music in his career, he didn't use computers to compose this concerto. I chose it for our exercise to give you a glimpse of how music can be organized in surprising ways, with relationships and structures that could be explored even more deeply by computers. Unsurprisingly, then, computers really can structure music according to logics that may not be readily apparent. There's no accounting for taste, of course, but these results needn't always be overwhelmingly dissonant or complex. There's no stylistic implication to using computers to make music either. These systems are reflections of their human creators and users, for better or worse. Here's a short example of a computer-generated fragment from one of my early systems. It's a draft made by the computer that I never finalized.
The boat gently oscillated.
I made the system, which I called Bearing Straits, because I was interested in using software to find new relationships between my musical materials. I'll talk more about it later, but one thing I'll say now is that I viewed the system as a collaborator. It proposed drafts that I could elaborate and refine, or reject and ask for more. Of course, I'm still working on these things, and this is work that involves research, aesthetic inquiry, coding, daydreaming, but aesthetic inquiry like this does not figure into the typical development framework of most online AI music tools today. The reasons for this are many: different training, and we'll come back to that word, training, different goals, monetization, the persistence and power of human assumptions and preferences. And of course, there are cultural reasons too. Music is just not an area that the public generally considers suitable for experimentation. But let's look at what the market has produced and what these technologies do. Google's well known Magenta project from 2016 was part of their portfolio of deep learning projects. It's an early neural network based machine learning system. In AI, a neural network is a computational system based on the way the human brain processes information in layers of neurons. The system is trained on a corpus or data set of existing music. And this is a really important detail. For the system, the only music that exists is the data set it's trained on, and it takes on board all of the assumptions, biases, stylistic features, and so forth of the music in the data set. The system learns the structural patterns and relationships in this music, similar to the way ChatGPT learns language by being trained on a text data set. Magenta can generate new music based on these patterns and relationships. Here's an example from Magenta's Music Transformer tool. I'm impressed by this. Magenta has generated a lovely jazz piano performance. It's harmonically sophisticated, that is, it's chromatic and it moves into different key areas. And it's also not overly repetitive. It has a good proportion of repetition to variation. And it's not stultifyingly predictable, but not so unpredictable as to be bewildering. Google Research went on to develop AI music generation from both text prompts and human singing. Music LM generates music instantly from a written prompt, like this one, which Google's developers provided on their website. A fusion of reggaeton and electronic dance music with a spacey, otherworldly sound induces the experience of being lost in space, and the music would be designed to evoke a sense of wonder and awe while being danceable. Now, I stress this is not a description of the music. This is the text that the developers gave to the Music LM algorithm to generate music. So the computer is reading this text and giving an intelligent result. So let's listen to how it interpreted this text. Okay. I'm not so sure about the sense of wonder and awe bit, but I guess you could dance to it. It sounds attractive, and I would say also a little formulaic, but we'd expect that. SingSong, another Google project, generates musical accompaniments from users who sing their input. The machine learning process here involves separating the voice and accompaniments in the music in the data sets, and then analyzing the relationships between them in order to be able to generate a new accompaniment for the user's sung input. So I'll play the input first. So this is someone singing into a microphone and giving the recording to the system, and then I'll play the result, the system generating an accompaniment underneath the singing.
When I'm gone away, no one will worry.
Okay, and here's the result.
When I'm gone away, no one will worry.
I think we can agree that these tools, including the music transformer jazz performance, represent impressive music tech achievements. But, and there's always a but, when I hear these outputs, my composer's brain starts to itch. I want to fiddle with them, change them, make them stranger, more unpredictable, less formulaic. I consider these outputs as first steps, not final products. And I think the engineers would actually agree with me, but for different reasons. Engineers always want to make things work more efficiently, for example, but efficiency rarely leads to better art. Soundverse is another text to music tool. It describes itself as an AI assistant for content and music creators that makes it easy to create music using a conversational interface and AI magic tools. I tried writing my own prompts with Soundverse. The first prompt I wrote asks for an experimental atonal cello solo. So a vague qualifier, experimental, a technical musical term, atonal, meaning not in a key, um, and an instrumental specification, in this case, cello. Let's listen to the result, which Soundverse titled Whispers of the Unseen Strings. Okay, I'll give it experimental and maybe even a kind of cello, but it's not atonal. It sounds more like an off-kilter G majory harmony to me, although the music is too short really to establish a key. I do love the crazy album cover Soundverse generated for this track, though. You can see it here on the slide. It looks like it should be called Antonio Salieri's Revenge or something. But the second prompt I wrote asks for something different, an extremely complex rhythmic and motivic construction. Motive is a technical word for a musical idea, usually a melodic one. For this piece, Soundverse actually wrote an entire song complete with lyrics and vocals. So let's listen to that. It's called Echoes of Melodic Intricacy. And as you listen, I want you to read the lyrics to the song that Soundverse generated.
In a labyrinth of beats and patterns we roam, complex rhythms weaving a tapestry of our own. Monovic constructions, intricate and bold, and a symphony of complexity, our story is told. Each note a puzzle piece fitting just right. In this musical maze we embrace the night, layers upon layers, building the sound. In this intricate dance we are spellbound. Time signature shifting, a mesmerizing.
Okay, it cuts off because I think you have to pay for the full version. So the most impressive thing about this for me is the inventive prosody. That is the setting of the words and their attendant speech rhythms against the music. The music itself is quite simplistic, especially the rhythms, but the vocals are set against the accompaniment in sophisticated ways, except perhaps for the pronunciation of the word tapestry. And the lyrics, while trite, seem to have some awareness of this, each note a puzzle piece, fitting just right. Our first reaction to this song, though, is probably to laugh. because it's delightful and amazing that a computer can do this, and also because it's overwhelmingly funny to take in all of this innovation. But I want to point out that we're not laughing as we might laugh at a Jacques Tati film or a line in a Samuel Beckett novel or even a stand up comics joke. And that's a distinction with a difference. We're laughing at the novelty, the novel absence of human agency. Beethoven presents itself as a background music generator. You can imagine all the commercial uses this sort of product might be aimed at. Interestingly, it gives the user access to the stems, that is, the separated vocal and instrumental parts of its generated audio, which are identified as melody, percussion, chords, and bass. Beethoven is also a text to music generator. The prompt I gave it was extremely dissonant, rhythmically complex, and aperiodic music for piano and string quartet. I really wanted to hear something that was not rhythmically formulaic. And admittedly, this was a pretty tall order. Here's one of the slightly glitchy outputs that Beethoven created, and I'll let you judge it against that prompt that I entered. Okay, I think we get the idea. I think this result is it shows the limitations of the training model, which is understandable. They're not training Beethoven on Milton Babbitt or Stockhausen or Boulez, alas. Mubert is another data set trained AI generator that takes written prompts. And for this tool, I tried some composer specific prompts. Prompt number one is music in the style of Morton Feldman. If you don't know that name, you might try listening to Feldman's piano and string quartet. Here's their Mubert's Feldman result. The calm mood is almost right, although the pitch material, that is the repeating of arpeggiated major and minor triads, definitely is not right. Although, now that I think about it, Morton Feldman did write a big piano piece called Triadic Memories, so it's possible that Mubert is playing a joke on me. Uh, Prompt two is electronic music in the style of our old friend Milton Babbitt. That's enough to know that this is not referencing the style of Milton Babbitt. We're all experts on Milton Babbitt right now, so I think we can make that determination. It's comically off, and the word electronic is clearly the determiner here. Finally, as a last example, we have Notagen, which was trained on notated music, 1.6 million pieces apparently, in order to generate new scores. Now, computer generated spontaneous musical notation has existed for at least 14 years, notably in the Maximus P programming environment, and probably much longer in the weird history of this kind of obscure stuff. But Notagen combines score generation with generative composition, and that's new. In other words, it notates what it composes. Its creators describe Notagen as being trained on scores similarly to how tools like ChatGPT are trained on text using large language models or LLMs. I became aware of Notagen, though, through a recent post about it on Twitter, which provoked some strong reactions. Here's the posted video of a Notagen score being played. You can read some of the reactions for yourselves. One of them is from the prominent and quite brilliant classical pianist Jeremy Denk. I'm going to stop it there. I want to acknowledge the technical achievement here by the development team, but I really can't disagree with the naysayers. It's not great. I expect that Notagen will get better in time, although better probably means something different to its creators. Better, I would imagine, means better at composing in the historical styles shared by the pieces in their data sets. For me, this kind of improvement is a little like a more accurate Civil War reenactment or building a better mousetrap. Now that I've given you a survey of some of the high-tech tools available today, I want to talk about my comparably less sophisticated approach. I'm inspired by things like early 20th century surrealism, cybernetics, and frog's eyes. Yes, frog's eyes. I'll explain. In 2014, I wrote a collaborative album, Estrates, with my Duke colleague and friend, Bill Seaman. We used Bering Straits to generate drafts of tracks, which we then selected to refine and complete. It was a three-way collaboration between two humans and a computer. The algorithms of the system were inspired in part by a 1959 article by Jerome Letvin and Humberto Maturana entitled What the Frog's Eye Tells the Frog's Brain, a classic in the field of cybernetics. In brief, the article describes how a complex result, sight, emerges from the cooperation of four strands of the frog's optic nerve, each supplying one simple bit of information. In Bering Straits, musical complexity results from the concatenation of many simple individual processes like sound file selection, duration changes, alterations of speed, direction, pitch, and application of sound effects. And then finally, from recombining those fragments into larger chunks that begin unpredictably to take on the features of melody, harmony, rhythm, and other elements. I always include a judicious amount of randomness to ensure that emergent patterns are eventually interrupted or somehow changed. I liken these sound file transformations to concepts found in the 1932 book Les Vases Communicants by the surrealist André Breton, and who adapted dream-related Freudian terms like condensation, displacement, substitutions, and alterations. Here's a short track from that album.
Coming to know the longing vocabulary.
The operand is an opera for 8 female voices, generative electronics, and generative video by Bill Seaman and me, along with the amazing team of collaborators you see listed on the slide. The idea was to take the generative, collaborative, creative process in the album Estrates and make it the subject of a live show. The computer puts the opera together, music, video, and text, in a new way for every performance. Moreover, the computer is actually a character in the opera. We call it the system. It has a voice, which is performed by Bill, and speaks to the singers and audience. The singers sing texts that they have learned in advance and also texts that are given to them to perform in the moment by the computer. Here's a 2-minute excerpt of the dialogue section performed by the singers and the computer.
The companion of silence, wind in the curtains, sleep overcomes, one tries to stay awake. In time, the window forms a duration, an interval, to a version of necessity. The moon is spinning, the palm is spun. The algorithms of landscape on the fabric of space. The manipulator of the apparatus, reading the text of clouds. The response of perception. We never see the same words twice. The tree is a forking code to the arc of longing, to the dance of the vanishing point, a figure falling to the ground.
My friend, the pianist and composer Conrad Tao, commissioned me to make a generative, interactive computer system for him to improvise with. The title, 100,000 billion pieces for piano and computer, is a reference to the famous Oulipo poem 100 000 milliards de poèmes by Raymond Queneau. Queneau wrote a sonnet in which each of its 14 lines has 10 alternative versions. 10 to the 14th power makes 100,000 billion unique poems. My system can theoretically make many billions more pieces than that, but you get the point. Conrad is a brilliant musician. He can play anything and in any style. And my goal was to make a system that could give him some material to start with, and then the system would respond to what he was playing. There are a variety of behaviors in these responses, from following and accompanying Conrad to disrupting and derailing him. The system tells him the basic harmonic structure it's using at the moment it's playing, but that's it. Everything else is improvised. The computer improvises and Conrad improvises. Conrad can also, in a sense, control the system. There are moments when he is able to change from a more harmonic texture to a more rhythmic texture. There are also moments where he can advance to a new harmony, but these options are not always available to him. The computer tells him when it's possible to advance. Conrad also has the option to record little bits of his playing, but after he records them, the computer does unpredictable things to them. I designed the system so that we can continue to add new sound files so the piece will evolve over time. Here's a short video of a storefront performance in New York during the pandemic. Conrad was inside the building, but there were speakers on the outside for passersby to become sort of the unexpected audience. my last example, I want to share an excerpt from a brand new piece, Crossed Shadows. It's a work for saxophones and tape commissioned by Red Clay Saxophone Quartet. It uses speech patterns to generate rhythms and even some harmonic and melodic components. I applied the Oulipo constraint of homosyntaxism with custom software I wrote to transform a one-sentence story by Amy Hempel. Homosyntaxism keeps the grammatical structure of a text, but changes the specific words used, the parts of speech. Next, I recorded the text and manipulated my voice with the computer. I then converted the manipulated speech into notes and rhythms. Finally, I fleshed out this minimal framework and freely elaborated it. The piece is very stylistically eclectic. It's an attempt to synthesize all of my associations with the saxophone, good and bad. And it's also a little mischievous. It sounds like it has grooves that you can tap your foot to, but as soon as you grab onto the beat, the pattern changes. And this happens again and again. So you're about to hear, as the final example, a short excerpt of an in-progress, unmixed studio recording. So this is not even hot off the presses. It's still in the presses or on the presses. I'd like to conclude with a riff on an idea Brian Eno raised in a 1996 interview with Andy Oldfield in The Independent. He said, quote, "I think it's possible that our grandchildren will look at us in wonder and say, 'You mean you used to listen to exactly the same thing over and over again?'" Eno seems to be anticipating the music of the future being so user interactive and customizable as to render the concept of a fixed recording obsolete. Think of it. We might be able to listen to an Elvis Presley song with Joni Mitchell singing, Art Blakey on drums, Eddie Van Halen on guitar, and Rachmaninoff on keyboards. Another way to describe this possibility is music as software. The software will allow not just the separation of these individual parts, as we have seen, but also training on the recordings of any artist, living or dead, to generate new performances by them. Speaking voices can be cloned, so can playing and singing styles. We're well on our way. In 2019, I was asked to contribute an essay on music to the UNESCO-funded interdisciplinary Handbook of Anticipation. In my essay, I quoted Eno's question and discussed music as software in the final paragraph. I'd like to read that paragraph now as a way of bringing my talk to a close. Whether or not music as software will be a good development for music is an unavoidable, if essentially pointless, debate to come. Societal trends regarding media consumption are on an irreversible course towards the infinitely customizable individual experience. This trend, when considered together with advances in technology, especially artificial intelligence, suggests software will change the nature of music in the way the printing press changed literature and photography changed painting. Composers and listeners alike will have at their disposal virtually limitless computational power to reimagine the experience of making and listening to music. As with prior advances in music technology, the piano, the metronome, the notation system, this future potential promises to produce new and startling works of music. But just what these new works might sound like is something the entire history of music has not prepared us to anticipate. Thank you. I'm happy to take questions if there's time.
Thank you so much, John. What a great presentation. Um, we have 10 minutes for some Q&A. If you have some questions, please put them in the chat. I'll get started, John. I'm wondering if you've thought about the implications with copyright for musical likeness. You know, where on the scale between something academic and something for profit does this become actually problematic?
Yeah, this is a huge problem, and it concerns musical artists. In fact, just recently I had a wonderful conversation with Tift Merritt, a singer-songwriter based now in Durham and actually teaching at Duke, about this. She's very concerned about her artistic work being used for training models and her artistic labor being uh, hidden and taken without proper acknowledgement or remuneration. And so I understand that as an issue. What I told Tiff was that I don't write the kind of music, and I don't think I ever will, that makes any kind of money. So I'm not worried about losing money myself or any kind of credit in that way. But um, it's a problem, and I'm not sure that there's an easy solution. I do know that there are companies out there that are commissioning their own content. So in other words, not taking recordings that have been made and released on records, but rather having people come into a studio and play and paying them to do this, but then creating a library for training data that they use themselves. So that's one way some companies are ethically approaching this question, but it's a bigger question that I'm able to answer in a brief response.
Absolutely. Thank you. We have a question from Tracy. Do you worry that AI generated music will lower listeners' standards of what good music is? Thinking about the Twitter exchange, and on that exchange, Jeremy Dank said, sounded bad, whereas to layman ears, it probably sounded pretty good.
Mhm. Yeah, this is a great question. I thought I might say something about what they mean by sounding. So you have to separate the performance, which is clearly some kind of MIDI or sampled electronic instrument playing back the score. So that could change. I mean, you could have a professional orchestra play this music and it would sound better in that way. But I don't think that's what they're saying when they say it sounds bad. I think they're saying that the harmonic progression in there in that piece is either rudimentary or it's sort of there's some wonkiness to it in the voice leading. So there's a kind of a technical critique in that word. It sounds bad. So yes, so that's one thing. And the other thing is to get back to the question of lowering standards. Yes, I am concerned because in order to make music more accessible, musical tools more accessible, a lot of the software makes assumptions on the music being made with them. For example, Ableton, if you open up an Ableton session, it gives you a BPM, it gives you a tempo. And so that will result in a lot of people, if they don't change it, writing music that's in 4/4 at 120 BPM. And just for variety's sake, that's quite, that's a shame. We want music in all sorts of key time signatures and tempos. So I think we need a way of thoughtfully approaching technology so that artistic inquiry can remain alive and active in our use of these tools.
Right. We have another question in the chat. Is there a concern about streaming services filling playlists with LLM style generated lo-fi music? And can we draw a distinction to algorithmic AI generated music that has a clear human creator?
Oh yeah. So certainly, I mean, I think a lot of these tools are going to be monetized and unthoughtfully so. And it's attractive to many people, people who make websites and content, this term content creators who need music. They don't necessarily care what kind of music, they just want to fill the silence of their videos. And I understand that. And I understand that not everyone could be a connoisseur of music. So there is some need for a kind of automatic instant music generation. But it is a problem that I don't have an easy answer to, except that people can vote with their dollars, and they can support uh, artists who are using this technology more um, in a more human and engaged way, that a more imaginative way, I would say. And the other part of the question was making a distinction between human music that uses these tools and the tools that are just sort of generating automatically. Yes, I think we know it's sort of like the Potter Stewart rule, right? You know it when you hear it. Um, you know when you know music is good, or at least is written with intentionality when you hear it. So I would say trust your instincts, and also remain curious, because as we heard with the Milton Babbitt example, there can be structures apparent that are not structures in the music that are not immediately apparent, that merit some closer listening, some closer thought. That's really the problem, I think, these days. We're so accustomed to thinking quickly, getting the first Google result, putting things in categories and moving on, that we lose the pleasure and the value of slowing down, reading closely, slowly, thinking deeply. I think that's really one of the ways we can combat some of the loss of quality of these automatic tools.
Mm. Mary asks, I'm interested in the idea of training data, in that whatever the AI generates, it can never be wholly original, as it's always based on what the training set is. Is that correct?
Yes, yes. So thank you very much, Mary. I love your question. I think we would be friends. So my huge critique of the training-based methodology of creating this music is just that it's limited to the universe of the music it's trained on. That's not how I write music, or how I use computers to write music. I'm interested. So basically, the critique is this: we're just perpetuating the biases in the music and the limits. And I'm not to say that, say, Mozart, it was limited. Mozart, of course, was a genius, and a much better composer than I am. But what I'm saying is, if you train a model only on Mozart and Haydn, you're going to get less good Mozart and Haydn generated by a computer. And so what I'm interested in doing is using computers to show me unexpected results that I can't imagine on my own, that I need the computer's lack of taste, lack of biases, lack of assumptions, and so that it can surprise me. And it can do it in a very efficient way. I know I said efficiency doesn't generally lead to better art. In this case, it at least allows me to make a lot of experiments very quickly, and to reject them just as quickly and move on. So I'm interested in sort of unexpected music that isn't based on training or learning.
What about synthetically generated training data?
Um, uh, eh, so I'm not sure I understand. Could the questioner maybe elaborate?
Right. We have time for just about one question. I'll let the questioner elaborate here. Is there any similarity to the AI models that we see elsewhere, like transformers guessing the next token and diffusion models going from noise to clarity, or are they completely different models? And is there any research into things that mix up visual and audio modality instead of text to audio or audio to audio?
Oh, I'm sure. Yeah. I mean, I chose the examples I chose because I thought they would be the most readily findable through a search online. But there are all sorts of other experimental ways the music is being generated. I think the main thing is that notes, as we saw with the Babbitt, it can be considered, data points, just like words or pixels. So they can be reorganized in the ways that, say, an image could be reorganized. So, something like Dolly creating new images. Those pixels could be likened to the notes of a score that would be regenerated.
Mm. That might be all the time that we have today. Thank you, John, so much. Thank you, everyone in the audience. These were excellent questions and a really, really great presentation, John. Thank you. So
Pleasure.
today's session was recorded. and will be posted to the Duke Alumni Lifelong Learning YouTube channel. Be on the lookout for a follow-up email with links highlighted today. And our next session, Understanding Social and Cultural Sounds, will be held on April 16th at 12 p.m. noon. We look forward to seeing you all at the next Forever Learning Institute. Thank you so much. And John, again, thank you for an amazing presentation.
My pleasure. Thanks for having me.